Hello, this is Dr. David A. Gaitros, Department of Computer Science at Florida State University, and I'd like to welcome you to my undergraduate lecture series on selected topics in computer science. You can find these videos and others at my YouTube channel at the URL listed below, or you can simply go to YouTube and search using Gaitros and FSU as keywords. Now on to the lecture. Today's lecture is on linked list. I want to show you a very simple linked list structure. Linked lists are very useful data structures in building a list of records in a sorted manner, in a very efficient manner. But the complexity of the software, the programs are a little much, but the gains we get out of it is well worth it. Alright, well, let's start off. I've got my basic little program right here, and I've got the code already written sitting over to the side here. I'm going to pull it in. I'm going to pull it in a piece at a time and show it to you, a piece at a time. So the first thing I have to do is I have to have a structure for the linked list itself. Let me make a few arrangements here. Okay. So I have a structure, and the idea of the structure is that we have a group of data items together that we can clump together and create a record, so to speak. The secret here is in the last part, and you'll see that my structure is called linked list structure, and it contains an ID and a name, very simple record. But then I have another linked list structure of the same name. This says asterisk next. This is a pointer, and what that pointer does is it points to a record of the same type of structure, and this is how we link things together. This will be the basis for our singularly linked list. It's a single linked list. Okay. We need that first, and the order of this isn't really too particularly important, but that's usually how everybody does it. Now I'm going to add something else. I'm going to add a function, and I'm going to use functions here to add records and to manage our linked list rather than try to put it all in the main routine. I'm going to try to do this in a professional manner. So I'm going to have a function called add record. Now to make this work, I've got to do a couple things that are very important, and this is something you need to pay attention to. I'm passing in the linked list structure, or the head of it, the very first record of it, and then I'm passing in the new record that I want to add to it. It's in a structure by itself, and what I have to do is I have to return that head, or the linked list structure, back as a function of the routine. Now some of you might actually be tried to say, well, I'll just leave it right here and pass it that way. That doesn't work. That doesn't work. If you do that, it's not going to actually change the called value, so it doesn't actually pass it back. So you've actually got to pass it back as a type right here. So that's also very important. Well, let's get this to work first. All right. So I'm going to go down here, and I'm going to add the functions to make this all work, or add a record. Let me get this right here, and now I want to insert this code in here. I want to explain it to you line by line. Okay. All right, here we go. Okay, so here's the start of our routine, and what I'm going to do is I'm going to add records to it. Okay, so I'm going to create the head of the list and assign it to null pointer. Initially it doesn't point to anything. I'm also going to use another structure just to read in the records themselves. The very first thing I do is for a new record, I go out and I get a new record of that, and dynamically storage allocate it, and then I enter in the ID and the name. So I enter in the ID. If the ID is less than 0, I just stop the program right there. I don't enter any records. If it's not 1, then I read in the name. I assign the next to null pointer, so I just have a basic record. And while the ID is greater than 0, I want to continue doing this. So the first thing I do is I add the record. Notice I pass in the head, which right now is a null pointer, and the new record. When it returns, what it's going to do is it's going to give me a new value back for the head of the list itself. And it's important, let me just qualify this saying, is that you studied linked lists ahead of time already, so you kind of understand how they work. Okay. Then I go back and I get a new record and I start the process over again. Right. Now let's go look at the function that actually inserts the record itself, and this is what's really interesting right here. Okay, so I'm going to pull in over here and I'm going to pull in the function that reads in the record, and I'm going to copy it. And of course our prototypes go up the top and the implementations go down here. So let's look at this. This is the routine that actually adds the record. I keep track of the current and previous. Now because this is not a doubly linked list, I have to find out where to put the record at. I don't know where to go until I'm past the point, so I have to keep track of where I was previously. Let's look at an example right here. Okay, let's say that I'm going to use this example. Let's say that I'm going to add Adria, my daughter's name, and then David. And now let's say that I want to add, let's say, Colin. Alright, well, Colin goes in between here. But if I'm looking at the records one at a time, I don't know that I wanted to add it until I'm past the point. So when I reach David, so I've actually got to put it right here, Colin, which means I've got to know the record previous to that and the one that I'm looking at, so I can change the links around. Okay. So, and I've got three situations that I've got to deal with. Okay. The first situation is, what if the head is a null pointer? In other words, what if it's an empty list? Well, if it's an empty list and there's no records to point to, that's easy. I just say the head is equal to the new record that I passed in, and I return head, and I'm done. So that's a very, very easy thing to do right there. Okay. Now, the second one is, what if I replace the head? I could probably wrap this into the same routine that follows it, but I usually make this as a special case that's a little more efficient. So if the name of the head is greater than the name that I passed in, that means then that replaces the head. What I do is I say the new record next is equal to head, in other words, and then I replace the head with the new record, and I return that age. The common case, which is this one right here, is whenever I've got to insert something in between or the last record. That's going to be most of the time. So I have to keep track of the previous and the current, and the previous one is equal to the head. I already know that it doesn't replace the head. I've checked that, so this makes it a little bit easier. Then I go ahead and say the current is equal to the next record. I know I've got at least two records at this point. And while the current record is not equal to the null pointer, which means it would be the end of the list, and the current name is less than the one I passed in, I want to continually doing this. I want to continually look at the next record, and that's what this does. I give the current pointer to the previous, and then I advance the current pointer to the next one. When these two conditions, one of these two conditions is met, I've found the place to put it. It's either going to be somewhere in between the record, or it's going to be at the end. Regardless, these two links right here is what actually does it. Now, let me make a note. This line of code right here can be very, very troublesome, and I'll explain why. It is the case that has to do with if I'm at the end of the list. If I'm at the end of the list, then the current pointer, it has a null pointer. That means it's not a valid address. Okay. The order in which you put them in here is very important. It always does them in order. So it checks first to see if it's a null pointer. If it's not a null pointer, then it will ask this question. If you reverse these two right here, you're going to get a segmentation fault whenever you try to add a record to the end of the list. So be very, very careful of that. Okay, let's run this. Let's build it. Okay, and let's run it. And we're going to run linked list, and we're going to enter in, we're going to say 1 David, 2 Cindy, 3 Heather, 4 Adria, and you'll notice, and then we'll put in a -5, and it stops. I didn't print anything out. So just inserted those records. We don't know they're inserted properly yet or not. We're going to write a routine that helps us check that. So the next thing we want to do is we want to write a print routine. It's a little easier than this one. Easier because it just follows the length. So we're going to go upstairs here and we're going to put in a prototype. Here's our print records, and I'm just passing in the head of the linked list. That's all I really need. I don't need to return anything. I'm going to start at the head, continue printing them until I get to the end of the list, and then I'm going to stop. Let me go down and write that function. Okay, here's the function itself. I'll copy that. Now this one's very simple. I just give it the head. I get the current is equal to the head. Well, the current is not equal to null pointer. Or if the current is equal to null pointer, I just go ahead and print out it's an empty list. That's, I didn't have to do that, but it's just a little extra thing I do. Here it is, while the current is not equal to null pointer, I know I've got at least one record. Then I print out the ID, the current ID, and the name. Again, this assumes you know structs, and then I get the next record. Okay, and this is how you traverse the list. Very, very easily done. It just goes to the next record. It doesn't follow them in sequence as in memory as you would an array. It just follows the addresses, and they can be, as an address goes, they can be in any order, but a linked list allows us just to put them in there in any order we want. Alright, let's go up and let's print out the list after we read them in. We're going to print them out and make sure everything's okay. So right here we're going to go up and we're going to say print records, and then we're going to say head, and then head. Okay, now let's build our program, and we're going to run it. Oh, fixing an error here. Oh. Yeah, right there. Sorry. I didn't copy everything. Let's build it now. There we go. Run, and we will do the same kind of thing. 1, David, 2, Andy, 3, Heather, 4, Colin, 5, Bill, 6, Anthony, and then -7 stops the whole thing, and see it prints them out, and it looks like everything is in alphabetical order then. So it looks pretty good. Alright, let's do one more thing. I'm not going to do a delete in this particular video here, but let's find a record. That'll help us. So we're going to say find a record, and what I'm going to do here is a little variation on the common themes you find. I'm going to find the record. What I'm going to do is I'm going to pass in the ID number, and what I want it to do is return to me the string or the name that's associated with that ID number. If it doesn't find one, what I want it to do is I want to send a message back that says it wasn't found. Alright, well let's write that code. Again, not very difficult code. Okay, let's go down here, and I usually put it right before the print. Okay, so here it is, find the record. I'm going to pass in the ID number and the head of the list. I give the head to the current, and while the current's not equal to null pointer, I check to see if that ID is equal to the one that was passed in. If it is, I return the name, and that stops the program, and I don't have to do anything else. Else, I go to the next record. If I get to the point where the next record is a null pointer, then I say return not found, and it prints that out. I'm not going to test that, but I am going to test to see that it did find the correct record. Okay, so we're going to go up here, and we're going to change in our main routine. Again, I'm just going to copy the tests that I've done already. I've proven the code works. Okay, print the records, and then we're going to come in here. We're going to say boom. If I'm going to just hard code finding record 1. I know I'm going to put that in there, and we can actually try this a couple times, see if it prints out the message properly. We're going to build it. Alright, and we are going to run it. Alright, I say 1, that's our record we're going to find. 2, Cindy. 3, Heather. 4, Colin. And you can see these kind of messages I print out just to kind of give myself some diagnostics. No other reason than that. 5, Anthony. Let's see, well, that's enough. -6. And there it prints it out and it says found record number 1, which is David. Well, let's run it again and let's not add record number 1, shall we? Okay, let's say 2, David. 3, Cindy. Indy. Cindy. 4, Heather. 5, Colin. 6, Pete. And then we'll say -7, record not found. Okay, good. Well, that is a very, very simple linked list. Singly linked list incorporates a couple of things: passing parameters, passing the list as a parameter and returning its value. Very, very handy. Very seldom you'll ever use a singly linked list, but this introduces you to the concept, and we hope you find it helpful. Look forward to doing another one for you.